So good morning, good afternoon, good evening, everybody, depending on where you are, and welcome to the second day of the webinar towards integrated soil and water management in Asia with a focus on soil salinity. Yesterday, we introduced the topic and got to know countries' priorities and needs. Today, we will talk about practices and technologies. We have a few speakers to break the ice, but we really count on your active participation to the discussion. So if you feel like sharing, we are willing to listen. To start, I would like to give the floor to the first speaker of the day, Dr. Gajender from the Central Soil Salinity Research Institute of the Indian Council of Agricultural Research in India, that will tell us about the cut soiler technology developed by his office. Dr. Gajender, the floor is yours.
Yes, I'm not getting the screen sharing options. And still not on the video, yeah?
Maybe it's because you didn't join as a panelist at first, but I did promote you. You have to accept my promotion to panelist, please, and rejoin. Let's see. Yes. Now you should be able to share your screen.
Hello, good morning.
Now we can see you. Good.
Yeah, happy to see you. Yeah, I'm Dr. Gajendra. I will talk about a cut soiler, the technology we are using for the management of salinity. And here I'm sharing my screen first. Yeah, is it visible?
Yes, not in presentation mode, but we can see. Yes, perfect.
Yeah, good morning all. We are using a cut soiler, that is equipment. We can use it as an attachment with the tractor that we are using for construction of the residue fields, subsurface shallow drains to manage the root zone salinity. First, we go in the little background that we talked yesterday a lot, but the salinity is a huge problem globally. But in India, it is also a big problem as far as agricultural production is concerned. We are having 6.7 million hectare of the salt affected land, and both sodic and saline land, and saline sodic area also we are having. And where the predictions is that by 2050, we are having salinity about more than 16 million hectare. Apart from that, our groundwater quality is also saline. There are 32 to 84% of the saline groundwater in different states. And it is a prediction that we can lose around 10 million hectare of land each year under salinity. In India, there are 17 million tons of the annual food grain loss due to salinity alone. And that on an sector economic loss is 2.75 billion USD. And apart from all our efforts of the salinity management, we are having pilot projects on the implementation of the subsurface drainage for the salinity management. And we are able to reclaim more than 2 million hectare by using gypsum, the sodic soils of Indo-Gangetic plains. But still, the different forces are in place, and the salinity problem is increasing due to there are various reasons of the increasing the irrigated area, the climate change, and the resodification, desalinization. And that's why we take an example of the state of Haryana, the salinity is in the increasing mode if we are compare it the figure of 1996 to 2026, and our recent data saying that it is increasing furthermore. So we are for the salinity management. I divide my presentation in two parts. First is that the salinity management, where we are having drainage and the leaching down technology. For sodicity, we are need some amendments like application of gypsums, and the gypsum. The constraint is that we can apply only on the surface soil and mix it. So we are able to penetrate the reclamation process using the amendment to the subsurface using this technology, and residue management. So first, the drainage technology that we are using, and it is working well, but there are some limitations of this technology because this technology needs a heavy machinery and a high cost. The subsurface drainage technique can be applied on a larger area. It needs a community approach because the holdings of the farmers in India is quite small. So we need a hundreds of hectares of area to implementation of the large scale subsurface drainage pilot projects. And that's why its adoption is less. And there are some socio-economic issues as well, because the upper part has reclaimed earlier, and then the farmers has lost interest in the pumping out of the water, and there is a complex issues of the running of the pumps and the disposal of the salty water that was drained out from the roots on salinity. So people are trying some different alternates of the subsurface drainage that can be applied on the small scale at individual farm levels. And here there are some approaches, but we are talking about the cut soiler approach, that is a machine that is used for a low-cost drainage construction. The advantage of this machine is that it is low cost. It can be operated with a simple tractor. It simultaneously manages the residue, particularly rice residue. That is a huge problem in this part of India, where the farmers are hoped to burn the rice residue to keep the field ready for the next crop, because no further other management of the rice residue. And it can be applied in a small farm of any shape and size, like any other tractor operation. So let me introduce the machine. This is cut soiler. This machine is introduced in a collaborative project with JIRCAS. It is Japan International Research Center for Agricultural Sciences. We are collaborating as an ICR since 2018, and we use this machine for the construction of the subsurface drainage. This machine was developed by Naro Japan and Hoki Kokai Corporation. So what this machine is doing, it swept the residue, available residue from the surface by this sweeper. And on the one side, we are having a blade. It can lift up a chunk of the soil in the V shape and create a slot where residue can be filled. And in that way, a continuous residue-filled drain can be constructed. This machine is operated with the tractor power. And there are some points that you should keep in mind while operating and constructing these kind of drains. So we have developed a user guide for making such kind of shallow subsurface drainage at the farmers level. So, first I will show you a small 25 seconds video so that you can get an idea that how this machine is working, and then we will go further for its implementation as the salinity management tool. It lifts up the surface residue very quickly, swiftly, and one side of the blade has open up, it filled with the residue, construct continuous residue filled drain. Yes. So we construct these kind of drains at the field scale just to standardize the optimum lateral distances for the effective salinity management at the representative saline sites. And we are having a controlled environment study where we have constructed manually this kind of drain just to look at its effect on the salt and water dynamics, how it is changes. And we are implementing it at the farmer's field level for the feasibility trial. So first, we are having a field trial where we are constructed this kind of drains at various lateral distances, say 2.5 meter, 5 meter, 7.5 meter, and 10 meter, just to look at the effectiveness of the desalinization effect of this kind of drainage at the field scale. And these two sites, one is a canal where we are having a controlled environment study, and at NAN Panipat, we are having a field scale study. Both sites are representative trial and salinity sites where most of the year you see the water deficit. And we have spread the residue on the surface and construction drain. And at the outlet, we are having small pipe just to facilitate the outflow of the water, and we connected it to a main drain, just like any kind of drainage project or subsurface drainage system is working with, collected from the individual pit and we take it to the main drain. And you see the effect in the 2 years. There was a reduction in the salinity, the average salinity that was up to 16 deciciment that was reduced to 6 to 8 in most of the field. And you look at closely, there was a huge reduction, up to 60%, more than 50% reduction when we are having closer spacing of the 2.5 meter. And there was likewise reduction in the salinity after 3 years. And this is that how long it is effectiveness of desalination is that if you consider the x-axis as the drain, that its effectiveness is up to 150 to 200 centimeter. It means that it is again justified that 2.5 meter spacing between the drain that is the effective for desalination. And this is the change in the pH. That is, the site is having some dominance of the alkalinity as well. So there was a predominance of bicarbonate when we are able to leach out or drain out the soluble salts. The soil is trying to become sodic. And this is the stability of the drains. The drain is effective up to 3 years in case of when we are filling it with the rice residue. Then up to 3 years, it functions well, the drainage function is okay, and after that you have to reconstruct it. And this is its effect on the response of the crops. The two prevalent system, pulp millet and mustard system in the dry land salinity where we are seeing it's matching response to the crop production. And these are some of the views. And this is the control environment study where we are simulated this kind of drains manually in the lysimeter. And we see the similar effect up to 50% reduction in the salinity after 3 years. And both kind of soils where we are using saline, light sandy loam soils and heavy textured soil. And this is over the years, the percentage changes in the salinity by using this technique. And this is the response of the crop, where we are desalinized, its crop production has increased. And this is that we are applied this technique at the farmer's field. This is a sodic site. Along with the residue, we have applied gypsum, and we are able to place the gypsum at the subsurface level around 55 to 60 centimeter below. And in that way, we are able to penetrate its effect in the deeper layers. And you see, and in the 2.5 meter later spacing, there was a huge effective reduction in ESP in the root zone. And that's why its reclamation effect has been penetrated in the deeper areas. And if you see the lateral distances, it is from the drain, there was quite effective up to 80 centimeter or 1.2 centimeter, means up to 1 meter, it is able to reclaim the soil at lateral. This is all about the introduction of this kind of technique we are using at the farmer's level. There are some drawbacks also. We are facing some problems and we are rectifying time to time, and we are promoting it to use for the farmers in the Haryana, Punjab, and some other parts of it. Thank you very much.
Thank you very much for the excellent presentation. Can I ask you if the video is available online? The video that you showed, if it's available online?
I can share with you, or I can make it available online on the website of the institute, either way you
Okay.
like. Yeah.
Thank you very much, because it was very nice to see, but because of the internet connectivity, at least to me, it didn't show like smoothly, so it would be very nice to have it. Let me invite all participants to ask their question to you, but also to other participants through the question and answer box that they have on their screen, and also eventually to raise their hand so that I will give them the floor for them to make their interventions live. We are going to have other two presentations, and then we are going to break for about 10 minutes, and we are going to have an open discussion. So that's how we are going to proceed. 3 presentation and then discussion. So Dr. Gajender, I kindly ask you to stay with us, keep an eye on the question and answer box, and then join the discussion in about half an hour. Now I would like to give the
Stop
floor.
sharing?
Yes, thanks.
Oh.
Thank you very much. Now I would like to give the floor to the next speaker, Dr. Wen Bolong from the Northeast Institute of Geography and Agroecology of the Chinese Academy of Science in China, that will tell us about solutions for rice wetland system production and ecological functions in saline alkaline areas. Dr. Bolong, the floor is yours. Thanks.
Okay, thank you. Can you hear me?
Yes, very well. And we see your screen.
Okay, thank you. Hello everyone. I'm Bolong. Come from Chinese Academy of Sciences. Thanks for giving me this chance. It's my pleasure to share our story here. For time limit, I will be a little quick. I plan to explain from background, practical work, and outlook. As mentioned in yesterday's report, salinity is one of the top 10 major threats to soil health. 10% of the world's soil is affected by salts, and about 10% of which in China. So the Songneng Plain in northeast China is a typical area affected by salt in arid and semi-arid region. The salt-affected soil in this area, we can call it soda sauce. The main type of salt is soda. So in addition, the high salt, the pH is also very high. It's very difficult to treat. This area has important potential for the increasing crop production. Now, the most useful method is to grow rice and the supply of water. The usual measure are firstly infrastructure construction, including the land leveling, irrigation, and drainage system construction. Then physical and chemical conditioners are added to help the washing of salt with water. And then salt tolerant rice are planted. The use of soda sauce to grow rice has achieved great success, including an increase in production and a change in the natural landscape. But the salt comes and goes with water. We should know that the measures are not only about improving the soil, but also preventing the secondary salinization. Not just the salt in the soil itself, but also the added salt. It's not just about the water quantity, but also the quality. Not just about agriculture, but also about the ecology. We can see a large number of lakes, marshes, also distributed in this area. Biodiversity conservation in this area is also very important for the global conservation. Many wetlands of international importance distributed here. The ecology is very fragile also. So how to balance agricultural development and wetland restoration and biodiversity protection and improve the water resource efficiency. So we selected a typical area and conduct the practices, hoping to provide a solution for the production and the ecological function of the rice and the wetland system. We took practice in the red dot, and the blue dot is a control village. So we can see the huge changes that have taken place after years of practices. We treat paddies and wetlands as an integrated system, taking into account various factors such as crab, fish, rice, birds, and so on. The most important is to achieve a balance between production and ecology, both inter and inner systems. First, the chemical measures is too costly and unsustainable. Aquaculture is carried out in the initial state to reduce costs, increase the profit, and reduce the salt salinity. After that, when salinity is controlled and production is increased several years later, further breeding can be improve water efficiency and reduce the agricultural inputs. Then grazing ducts after harvest to control insects and grass seeds for the reduce the chemical inputs and help store retain the soil. Secondly, treat the drainage from paddies with engineering wetland to reduce pollution loads and regulate water resources. Our practice have proved that the reduction of pollution has effectively protected the health of natural wetland. Another practice is to use the final tailwater to restore wetlands that have been degraded due to the drying. With the hydrological regulation and vegetation restoration technologies to restore wetlands. As you see from this picture, the recovery effect is very encouraging. The whole wetland landscape is maintained and restored. On this basis, in order to ensure the sustainability of the restoration project, we also developed the ecological products and carried out different cycling models. For example, by controlling the density, we breeding fish and crab in marshes, and then harvesting reeds in winter for paper making and power generation. In particularly, we have created a method to produce mushroom using reeds to turn and then turn the waste into fertilizer to improve soil. We use the natural and restored wetland to regulate flood resources and ensure regional water security. In spring, the paddies are irrigated in time with the flood water resources stored in the wetlands. And when in the rainy season, waters are stored in wetland to protect rice from flooding. On the basis of improving crop production and food supply, the ecological benefits are very significant and biodiversity increase, such as bird diversity and fish diversity. And then even the local microclimate regulation functions are improved. The scale of our technology applications is rapidly expanding, and various social benefits increase quickly. Rural communities undergo historic transformation. We can see the huge change. Finally, there are few outlooks. First, good overall spatial planning should be done to separate production of land from ecological land. Then a whole monitoring and management system is needed to ensure the scientific management. And the drainage treatment system at the engineering wetland should be popular and applied as a green infrastructure between the farmlands. We all should shift from getting food from the croplands only to getting food from the entire land. And I want to repeat here, although we have made achievements in food production, we can't pursue speed and damage the ecological environment. In a word, we should from kind produce food to not only produce food. Thank you for your attention. That's all.
Thank you very much, Dr. Wen. It was a very interesting presentation, and I myself have some questions for you to ask you later on. Again, please, if you can stay with us, we have one more presentation and then we will open the discussion. And if you can please also keep an eye on the question and answer box. Thank you very much again. Your presentation was very nice and interesting. Now I would like to give the floor to the next speaker, again from India. It is a pleasure to give the floor to Dr. Yadav from the Central Agroforestry Research Institute of the Indian Council of Agricultural Research that will tell us about forestry in salt-affected soils. So Dr. Yadav, the floor is yours. Thanks.
Okay, thank you, ma'am. Thank you, Lucrezia. But there is a small change that Dr. Yadav is busy in some other assignments. So on behalf of him, I will present before you about this topic. So if you give me the chance, then I will share the slides now.
Sure, thank you very much.
And myself is Dr. Rakesh Panyar, working here as a principal scientist in the Central Soil Salinity Research Institute, which comes under the umbrella of this Indian Council of Agriculture Research. So before I would go to the topic, I must say good morning from India, good afternoon, good evening to all who are joining virtually to this very pertinent seminar that is in the soil and land management for sustainable, you can see the targets, that too with the salinity. So the topic I will cover in three parts. One is about the general introduction, then about the salinity status globally as well as the Indian context. Then we have some of the case studies on which we did the forestry operations, forestry practices, and we come up with the very relevant technologies that are very good to for managing this, particularly these artificial lands. Then we have a how we can what are the main prospects that how we can you can say go in the future. Then what are the future challenges, and at the end with some take home messages about this.
I'm sorry
So-
to interrupt you. Can you please start the presentation modality? Because otherwise the text is very small. Okay, perfect. Thanks.
Okay, no, it's fine then. So, as far as that, you know that this salinity, it's a very rising problem, and it causes a yield loss, particularly to the, you can say, the agriculture lands, and pertinent to the arid and semi-arid regions across the globe. And the transforming salt-affected soils, you can say, into a rich biodiversity models, it's a very challenge. And on the other context, if we are taking that all the flora that are very, you can say, not good for the such a hostile environment that is ingressed with the salts, but on the other hand, we are taking the advantage of the woody perennials that are somewhat tolerant as when we compare with the animal species. So by taking this advantage, we will go for the research and development to develop some of the models. There, this, as you know, this Central Soil Salinity Research Institute is a premier institute working in the managing of the salt-affected soils and come up with a very, you can say, the alternate land management technologies that is pertinent to the forestry operations with the course of the time, or we can say at the inception of these institutes. And forestry, not now, but from the past, it has been recognized as a very important tool for, you can say, improving the salt-affected soils in particular and marginal lands in general. It has the capability to increase the soil fertility, then the soil organic carbon, then leaching of the salts, particularly in the salt-affected soils. And finally, it will address the different, you can say, the climate vagaries that we are facing nowadays. So with this institute, it has, you can say, gone with the passage of the time that it has started with the forestry operations, with the conservation approaches, and with the passage of time, it converts the conservation approaches to the production approaches. As we all, you can say, have the products from this, you can say, the salt-affected, you can say, the poor salt-affected soils. In the past, we have worked on a different, you can say, the forestry practices, right? From the, we are main concerned about the plant survival. We will go for the, we have gone for the plantation technologies. Then we have some delineations of the salinity tolerance about the species. Then we are working at the currently, we just try to make the understanding about the anatomical, physiological, and biochemical mechanisms through the different, you can say, the species, that how we can increase the, you can say, the salinity tolerance. Then we go for some climate resilient borders with the high value trees as well as the other trees. Then we will work on the, you can say, the working of the waterlogged saline areas. That is a very, very problem for the inland salinity, where the secondary salinization is the major problem. Then ecosystem services evaluations. Then in the future, we will go with the molecular breeding and the conventional breeding approaches with some high-end outputs. And we have also worked with the anatomical and hydraulic traits of the trees under stress trees. And we will incorporate some use of real-time monitoring devices to understand the different mechanism that are happening in the plants when it goes for the abiotic stress. So along with this institute has come up with, you can say, with the different technologies. And for your information, as you know, in this salt affected soils, they are present everywhere across the globe. But as far as this Asia Pacific region, it has a major chunk, and the more than, you can say, the 6% of the world area is affected this particular salinity, and more than 100 countries they are facing this problem. And the big problem is that 76 million hectare saline area that is due to the human induced salinizations, and that too in the areas where the lands are very, very fertile and cultivable. And out of this 20% in agriculture land concerns. And There are different types of the salt-affected soils, and we categorize on the basis of the availability of the salts, right from the slight, moderate, high, and extremes. And when you see the only the first two categories, that is, you can say the slight and moderate, then it comes out to be 85%. So we can say that the 85% land of the salt-affected soils, they can be managed easily with small interventions by devising certain technologies. As my colleague Dr. Gajendra has also given some of the, you can say, the bites about the salinity in India. So here in India, 6.73 million hectare area is affected this problem. That is through the sodicity as well as the salinity. And this is supplemented with the another problem, that is 32 to 84% of the groundwater. It is also of a poor quality, and it is aggravating the situations. And it affects the 17 million tons of the annual food grain loss we are facing in this country every year, and we are converting it into a, you can say, the exchequer states, you can say the country's exchequer. Then it is about 23,000 crores we are facing the loss of, you can say, the Indian rupees. And overall, this is a very general slide that there are only four options for managing the salt-affected soils. One is the hydraulic management or hydraulic aspects, in which we are focusing on the irrigation management, that is under this leaching, drainage, mulching. Then we go for some of the mechanical options, that is we are doing the land shaping technologies. Then we create the dikes, raising the, you can say, the change the topography. And then the third option is the amendments that covers the, you can say, the chemical amendments as well as the organic amendments with the gypsum and the other things also. Then finally, the cropping systems, right from the salt tolerant, you can say the trees or as well as the crops. We are using this capability of the flora that how we can create a, you can say, the productive landscapes, particularly in the salt-affected soils. So as far as this forestry is concerned, we devise the plantation technologies depending upon the type of the salt-affected soils. So mainly we have three categories. One is the alkali or sodic soils. For that, we have developed the overhold techniques, and with this technique, we have reforest or afforest 60,000 hectare area. And the benefit cost ratio of this is 1:1.6. And it's a, you can say, very good technique to green the particular the sodic areas. Then we have a saline areas. For that, we have a subsurface or furrow irrigation techniques. And you can say in the photo, you can see that the in the rhizosphere there is a salt load is less as compared to the outer periphery of the this, you can say, the furrow. And the other category, that is the waterlogged saline soils, we have a raised ridge techniques, and in which we are, you can say, raising the plantation particularly to address the waterlogged salinity. And here, this slide I put deliberately that just to show you how the salts they are moving in the rhizosphere. So finally, at the base, you can see the subsurface furrow planting. So in the rhizosphere, you can see the very low salt load as compared to the rich trench and subsurface planting. So then we do some delineations of the, you can say, the different tree species on their salinity tolerance, right from the sodic soil as well as the salinity and as well as the waterlogging. So here, for example, in the sodic soils, when the pH is more than 10, then we have a option to grow the trees which are very, you can say, tolerant, but we are not going for the fruit trees. So likewise, in the other categories up to the 9. And if you see this slide, so we can infer that when the pH of the soil is low, then we have a good number of the species to grow for that area and have a very high economic values. And similarly, for the inland salinity as well as the, you can say, the coastal salinity, we have a different species, and we, you can say, evaluated in a controlled as well as a field conditions. And in the waterlogged saline areas, we have also very promising, and you can say, including grass species, we can grow it very well. So as far as some of the very pertinent, you can say, the case studies we did in the at the institute level. The first more is the Bichia, that is a Bichia forest model, where we, you can say, devise the technology of overhold techniques. And here, the main thing which I want to share with you that we identify the, you can say, the transitional phase. When we go for the plantation, we studied for 30 years of a plantations. And we can identify that the transition phase where the maximum, you can say, the reclamation and the fertility improvement was, you can say, obtained, that is a year between the 3 to 7 years. And that other things, there is a reduction in the pH, low in the salinity level, the other things also there. And in the between this transitional phase, we have came across with the prominence of the sodium detoxifications as well as the salinity elevations, and collectively this will lead to the restoration of the fertility of the soil. And another model, we can say another experiment we did in the, you can say, the strongly alkaline soils, and we have evaluated more than, you can say, the 10 or 12 species. And on the basis of the biomass, we can come to know that after 10 years, that this, we can say, the Prosopis juliflora, Acacia nilotica, they have the edge over the other species as far as this biomass return is concerned. And when we talk about the reclamation potentials, so again, we can say that when we compare it to the initial status, all the parameters of the soil like pH, electrical conductivity, soil organic carbon, and even you can say the bulk density, essential salt, they are less, you can say, continuously decreased with the passage of time in all these species. And finally, again, we can say that the species are good for the reclamation process. Another, we have a weed forest model where the highly calcareous soil was there, and we also developed a model, and we could find out that Tamarix articulata and Acacia nilotica, Eucalyptus triticonius, Acacia tortilis, and the Prosopis juliflora. These species, they are come up with a very, you can say, the edging output in terms of the, you can say, the biomass, and as well as we can say the reclamation potentials when we compare the data of the 3 and 8 years. And we have another farm at a Nain Panipat in the northern parts of the country, and where the problem of the saline salinity is there. And we developed there two models. The one is with the Eucalyptus triticonius, and another one with the Media composita. And here we, you can say, judiciously use the saline waters also with the different salinity regimes, right from the 4, 8, and 12 decicillion per meter. And we could find out that after 7 years, we could have a good survival of both the species in, you can say, in such areas. And we find out that the good quality water, they have the edge when we compare with the rest of the salinity irrigations. But here we can say when we are using the saline irrigation water up to 8 decicillion per meter, then we have a significant gain while we compare with the good quality water. And when we move towards beyond 8 decicillion per meter up to 12 decicillion per meter, then we have to compromise the, you can say, the on the basis of the yield particularly, and we could find out that 30 to 35% biomass can be compromised when we go for the 12 decicillion per meter salinity level with the normal waters. And the other soil parameters like soil ECE, pH, organic carbon, nitrogen, phosphorus, and potassium, they are in a better range while we compare with the open fallow areas. And again, one more thing we have observed that the water table, particularly under the eucalyptus plantations, that has gone down better or higher as compared to the, you can say, the other tree-based system, that is the media, and we can say have the other things also. And another thing we have developed for the, you can say, this eucalyptus species, they are best for these particular areas while we compared it on the basis of the biomass, carbon stock, carbon sequestrations, and other things also. And then finally, we have a Salix clone. We worked out for the, you can say, the waterlogged saline areas, and then we can come up with the recommendation that J799. It is a good, you can say, and could be an option for the waterlogged saline areas where the eucalyptus is only the option today. And other, we have also worked on the TVO. So Arbequina variety cultivar, it is good for, you can say, the greening of such lands. And the one very important and pertinent model for the highly sodic soil, that is a silvipastoral system, where the pH is more than 10, and 3 species, that is Prosopis juliflora, Acacia nilotica, and Tamarix. It has been tested, tried with these some grass species, and from this we can come to know that after 4 years, the soil, it becomes, you can say, good for growing of the other palatable and economical species. And another, we had developed the biodrainage technology with the eucalyptus. So here, eucalyptus is transpiring, you can say the good amount of the water, and it comes under the category of phytophytic plants, where it has the capability to absorb the water from the water table. And the closest spacing, that is the 1:1 meter, is the better to have a higher drawdown. And one of the observation we could find out that 0.85 meter to the 2 meter drawdown was observed in the 3 and 5 years subsequently. And we have a certain other species also where you can also try on this. And another technology we had the use of the, you can say the domestic seaways as well as the industrial effluent through the forestry operations. And popularly, it is named as a canal technology. And it is popular, you can say, very well adopted by the industry people in the whole of the country. And here in this, we could find out that the eucalyptus, we have tried eucalyptus, lucina, and one more species that is a poplar. And here we can find out that the eucalyptus has the capability to transpire 1.5 times higher, you can say, as compared to the annual crops. And when we compare it with the open pan evaporation, then it is about, you can say, 0.9 or 0.95 higher rate of transpirations. So we can say that it is a good technique to address certain, you can say, the environmental issues also. And on the other hand, we can meet out the industrial raw material demand. And finally, the prospects, particularly in the aspects of the forestry operations, as you know that the Indian Forest Policy 1988 and Draft National Forest Policy 2016, that clearly emphasizes that the total area of 33% should be under the forest or the trees. And now recently that COP held in 2019 at New Delhi, the Indian government has made the commitment that 26 million hectare area it should be forested or bring into the tree cover by the 2030 to address some of the land degradation net neutrality issues. So we can say the marginal landscapes or the particularly the sought after landscapes that have the edge to bring these areas into the, you can say, the tree cover. So that's why we can say have the scope to increase particularly to forest these particularly soil affected soils. And then we have a prospect to introduce some high value trees, particularly as previously we are doing some of the tree species which are highly tolerant, but we are now moving towards the aspects that they will give more to the farmers in on the aspects like biomass and the other byproducts also. So finally, we can say there is a scope to increase the salinity tolerance of some of the trees, particularly with selection approaches, some highly improvement, high-end approaches that we are going. And finally, we will create a tree genomic consortium for the sought affected sites. And then some field protocols for the valuation of the plantations for ecosystem services. And on the other hand, there is an opportunity for the rural youth to have a entrepreneurship, particularly on the forestry, for plantation operations, for nursery raising, management, valuation, harvesting, and other things also. And then creation of a farmers and industrial interface mechanism for sustainable management of the sought affected soils. And finally, some of the challenges that we are facing in particularly in foresting the sought affected soils, that we have a dearth of a improved tree clonal planting materials across the globe. I am not talking about the Indian only, Indian context. And there is one more challenge is that the reclamation process, particularly with the trees, is slow, and there is a need to club or integrate with the other, you can say the chemical amendments or the mechanical amendments to make it more faster as the other farmers or the you can say the agencies having these sought affected lands. So this is a very major challenge, and we are going to address in the coming times. And finally, there is a problem of the quality planting material that facing everywhere. If the quality planting material is good, then we have a good plantation orders. So finally, we have some of the 3-4 conclusions we can draw from this presentation, that from the last, you can say the more than 4 decades of the journey of the research and development in sought affected soils, particularly done by the Soil Salinity Research Institute India, the approach has been changed from conservation to the production. Then we have plantation technologies, alkali soils, overhole, saline soil, subsurface furrow, and we can say the on waterlogged wastage. And introduction of the high value trees particularly, and eucalyptus, it has the edge, particularly in the as a biodynamic species, and for particularly for the, you can say, use of the domestic sewage and the industrial effluent. And finally, we have felt the need that there should be an integration of the real-time three stages monitoring system and value addition options, then some valuation protocols for the ecosystem services, and some of the capacity building operations with the advanced techniques. So we are, you can say, very pertinent, we can say, particularly for the, you can say, the forestry operations, particularly in the certificate soils. So with this, this is all about myself. Thank you very much for providing me the opportunity. Thank you. Thanks a lot.
Thanks to you. It was super interesting. And as promised now, we are breaking from the presentation cycles and we will open the floor for some discussion, especially with the three speakers that presented on what's happening in their countries, so India and China. Yeah, with everybody. So please, again, feel free to raise your hand and I will give you the floor to ask your questions or make your statements live. If you're shy, you can use the question and answer control, but don't feel shy, please. Yesterday, you promised me to be very active today. So we really want to know what's happening in your country, maybe also making a comparison, not to what is happening in India and China. So from paddy fields to forest and more. Anyone feels like taking the floor? If you need of some time, I can start by asking some questions that I personally have to the presenters. So I will go in order. And I will start with Dr. Gajender. So my first question is the following. The subsoiler that you presented that looks amazing is actually available on the market? Like if a country in the region feel like using it, would they be able to purchase it, or how does it work?
As of now, it is we are having only one machine. That is in the project. We are implementing it at the farmer's field. But yes, we are in the process of release the patents, and we are in the discussions at various levels, including the headquarters in Delhi and with the Japanese counterpart. And I think by the end of this year, we are able to start its manufacturing here in India.
Thank you. And then I was curious, is there any condition under which the subsoiler doesn't seem to perform very well?
Yeah, it is. It is it is not able to control when the water table is on the surface. It is generally controlled when the seasonal water logging is there, and the conditions is to construct the drain is available, means a slightly depth is needed to construct the unlike drainage, it is not function in the when the water table is practically on the surface. The second thing is that it need a bit higher power tractor, like 60 horsepower needed for that. But in many areas where the holdings are small, the peoples are operating with the small tractors because its machine's length is a little longer. And it depends on the soil type as well. When the soil is quite hard, when we are having higher silt and clay content, it need a more tractor power. So we need to find out a bigger tractor relatively what the farmers are using ordinarily in this region.
Many thanks. I have just a last question, more like a curiosity. The impacts of the subsoiler, did they prove to be different in relation to the crop residue? Like maybe because, I don't know, we are talking about rice and then another crop residue. Is there a difference in impact in relation to the crop?
It is different because rice residue, it is because of its higher silicon content, it is quite stable. So it form a stable kind of drainage. And we are in the various stages of the experimentation where we are using many kind of residue, because rice residue is available on the rice only in rice wheat belt. But in other dryland salinity area where the cropping system is different, what kind of residue like mustard residue is available, like maize residue is available, and sugarcane bagasse is available, and cotton stalk is available. And we are having experiments at different stages using different kind of residue and their stability and their efficiency in the drainage function.
Thank you very much. And I'm happy to have broken the ice because we have questions coming in. So let me ask you another question from the Q&A. What is the optimum depth for cut soiler technique in light of heavy soils? In light and heavy soil, sorry.
Yes, the optimum depth in lighter soil is 60 centimeter, can say. But in heavier textured soil, if you are not able to pull the machine because of the hardiness of the soil, just make it a bit shallow. The one wheel that is visible on the machine, that is the depth control wheel. So as per your requirement, it is for the proper drainage function, it is around 60 centimeter, but you go up to 35 to 40 centimeter as well. In the heavier texture, the shallower, and then the lighter soil, it's up to 60 centimeter or more. It's suitable.
Thank you very much. Please keep an eye on the question and answer box, because based on the experience with other webinars, question can arise even a bit later in the discussion. So thank you very much, Dr. Gajender. We will get back to you as participants start engaging more. Now, I would go to Dr. Wen. Let's see if we have the same luck to engage participants. So I have a few questions to break the ice. So first of all, congratulations on the project. It looks amazing. And I think that the results of your project have very practical implications also for other countries in the region that face the same issues. So I was wondering, in your project, did you happen to deal also with iron toxicity?
No, we don't face this problem. We just treat the soil with high pH and high salt.
Okay, and did you find any relevant finding in relation to the practices that you applied and greenhouse gas emissions?
I have several students just monitoring the greenhouse gas emission. Some measures of our workers are can control or help the gas sink, but some will let it emission more.
Thank you very much. Dr. Rai, I see that you also want to engage in the discussion. Please.
Good afternoon. I'm Dr. A.K. Rai from Central Soil Salinity Research Institute, India. My question is to Dr. Wen. I would like to know whether your project area is in a coastal region, whether it is a inland salinity affected area or the coastal salinity affected area.
Our work is just in the inland area, not the coastal area. It's in the arid or semi-arid area in northeast China.
So that much salinity is there so that we can grow the crab. It is our understanding that it is only in the brackish water kind of thing. So just I would like to know whether that kind of salinity exists in that inland salinity affected area in your country. Whether it is it suitable for growing the crabs and all those things?
Yeah. we just bring the little crabs from the coast, and then we treat it with the different different salinity waters and let him suitable for the new environment.
Okay, thank you. Thank you.
Thank you.
Thank you very much, Dr. Rai. And Dr. Wen, let's give it another try. Is there anyone from the audience that feel like taking the floor? This is your opportunity. Seems like we are not getting lucky on this, this round. Yes, no, wait. What do they say? Congratulations to all the speakers for the excellent speech. This is a general question to all the panelists. What are all the hurdles and challenges you are expecting on the salinity management under changing climate scenarios? Dr. Wen, you first, please.
I think the most important face this problem. It's very important that the farmers can profit from this work. Then our work can keep sustainable. Otherwise, it just shorter work can keep it a long time.
Thank you. Dr. Gajender?
I say that the climate change scenario will change the salinity dynamics entirely. Because it is all the function of particularly of the rainfall and the temperature. So if the changes in rainfall you are expecting, say in some areas, even though the rainfall has increased, it's the number of rainy days has decreased. It means you are getting higher the runoff and lesser leaching. The less water is available for leaching. So those areas which are not saline now, they are expected to become saline. And likewise, the temperature, the evaporation has increased. So this is going to be a much bigger problem in near future as far as salinity is concerned.
Thank you. Dr. Jadav, do you want to take the floor? I'm sorry, I didn't catch your name. I know you are not Dr. Jadav.
Okay, ma'am. No problem. So as far as this climate scenario that is changing and how this salinity is affecting, in my viewpoint, two main factors are there. One is the temperature and another one is the rainfall. So particularly in the saline areas, as Dr. Gajendra said, there is a chance to increase the saline areas particularly. And with the temperature flux, you can say the more salts that are in the deeper layers, it will come upon the surface soils, and again it will create a big problems. And forestry operations, particularly the forestry practices, they have the edge to address all these things. And we are in a, you can say, with the row to address these particular issues, particularly with the plantation technologies as well as, and to, you can say, screen out some of the species which are more tolerant to the change in the climatic scenarios as well as to the changes in the soil dynamics. So all these things we have to see particularly to address these particular climate change issues.
Thank you very much. Dr. Rai, do you also want to step in? Thanks.
Actually, in climate change, there are three drivers like carbon dioxide, change in the carbon dioxide concentration, temperature, and the rainfall events. All these three factors will affect the process of salinization as well as solidification. With increase in the carbon dioxide concentration, as it is expected, it may lead to the process of solidification. It will affect the precipitation and the dissolution of the calcium carbonate, and it will ultimately have effect on the saturation of the sodium on the exchange complex. So this whole process of solidification and its replication is likely to be impacted by change in the carbon dioxide concentration. Apart from that, temperature and the rainfall. As Dr. Wen very rightly said, water is cause and water is remedy for the salt affected soils. So change in the rainfall pattern, the rainfall intensity, all these will have impact as well as the increase in temperature. It will have impact on the evapotranspiration requirement of the crop, and we will have to be more dependent on the irrigation sources. And in those areas, just like in India, where the groundwater quality is very poor, and in different states, if you see the statistics presented by Dr. Gajendra, they vary from 30 to about 80% of the groundwater resources are poor. Like that situation anywhere in the world existing, it will increase the dependence on those poor quality of water because livelihood is to be secured. First requirement of human being is the food. So just to grow their food, they have to depend on the kind of water application, and this will ultimately add more salt. So definitely the amount of water available for leaching will vary depending upon the intensity of the rain and the distribution of the rain. And the evapotranspiration will also change, and that will increase the dependence on the groundwater. And in nutshell, the totality, definitely there will be the area increase in the area where the soil salinization will have greater impact in the irrigation command area where the poor quality water is the major source of irrigation. That is my point.
Thank you very much. Dr. Pirach, we didn't hear from you yet. Good afternoon. Would you also like to step in to answer this question? We cannot hear you. You have to kind of, okay, now. Yes?
Can you hear me?
Yes, good afternoon.
Good afternoon from Thailand. I'm Phairat Pongvichian from Land Development Department. For this point, I think for the climate change, maybe increase the level of salinity problem. So LDD try to transfer the technology, especially try to promote the use of organic fertilizer to improve soil fertility and try to support or provide the water supply to the farmer, so it can I think it can reduce or help the farmer in case of change in the climate change. Okay.
Thank you very much. And many thanks also to Dr. Pillai for asking the question. It was very interesting and actually allowed us to engage with all the panelists of today. Now, in order to conclude this first round of discussion, let me go back to Dr. Jadav because I promised him some questions. So now my questions will come. I have one technical question that is the following, and then a curiosity. The presentation was very interesting. You presented many technologies and many thanks for that. I have a question if you happen also to relate your study to the nutrient content of fruit trees. So to make this relation between soil and actually the nutrient content of the fruits or the leaves of the fruit trees.
Okay, ma'am. We have also studied some fruit trees also. But you can say due to the paucity of the time, I could not present here. But we have derived the relations with the fruit trees also. And moreover, we can say the work which was presented, it is pertaining to the strongly sodic or saline soils. And fruit trees, they are come upon a, you can say, low and moderate salt soils. So that is there. And we have connections there also.
Thank you very much. I was asking you because the FAO Office for Asia and the Pacific actually is about to initiate an activity that really looks at evaluating the impact of different sustainable soil management practices on also food production for cash crops. So we also want to make this link between soil parameters and nutrient contents in plants. And for this, we are also establishing a regional working group. So I take this opportunity to make an appeal to all the soil experts in the call that feel like joining this work to please send me an email. The last one is a curiosity because in your very last slide, you mentioned something that came as a first during this webinar. You mentioned youth. And youth is super important in the region. We are trying really to work on bridging generational gaps. So I was wondering if you feel like giving us a hint on what India is doing regarding youth in agriculture.
Pardon, I could not get you. What do you want to ask from me?
Yes, youth, young people.
Yeah, ma'am, because this country is, you can say, going into a skill development. So for that, and there is a problem how we can retain the youth, particularly in the rural areas, because there is a more pressure on the cities. So that's why there are certain entrepreneurship, particularly in the forestry operations for raising, you can say, the poetic planting materials. Then we have a very small groups that doing the plantation operations particularly and mobilizing the people to go for the move plantations operations. So on that pretext, you can say, give a thought, you can say, fight of thought that we can move ahead in this direction, that how we can you can say to create the interest of the youth, particularly to the forestry operations. So in this way, we have two advantages. One, they will get the jobs, you can say the work to do, and on the other part, we can address some of the climatic issues very, you can say, diligently. So this is my viewpoint to particularly highlight that good point.
Thank you very much. I heard you very far away, but still I could understand what you were saying. But yeah, it was fine. Thank you. Let me ask again the audience if they have any question for you. So forestry and salt affected soils. Anyone's have any question or feel like making any live intervention? You can still do it in the question and answer box later on if you feel like. Okay. We are not lucky in this case. But thank you very much for your presentation and for all your answers. And again, please, if you can keep an eye on the Q&A because questions are coming. Just it takes a bit of time. So many thanks for the first three speakers of today. We are now moving into the last part of the webinar, and we will start with Thailand. So the next speaker is Dr. Pirach Pongwichan, expert on saline soil management at the Research and Development for Land Management Division of the Land Development Department in Thailand. Dr. Pirach will provide us with an overview on soil salinity management in his country, so in Thailand. Dr. Pirach, the floor is yours.
Thank you very much, Logo Cassia. Good afternoon, everyone again. It's my pleasure to be here today. I would like to take this opportunity to talk to you about overview of salinity management in Thailand. I will start with the basic information of Thailand. Thailand is located in Southeast Asia, and the total area is about 51 million hectares, and agricultural land is about 23 million hectares. The economy of Thailand depends very much agricultural production. Although ทำไมมันไม่เลื่อนปิดอันนี้ให้ Although Thailand is a cultural country, but there are many agricultural problem soil. The main problem soil are organic soil. It cover an area of 55,000 hectares. For the acid sulfate soil cover an area of ย้อนกลับเดี๋ยวเพิ่งกดอีกเดี๋ยวกดเอง For the acid sulfate soil cover an area of 867,000 hectares, and for saline soil cover an area of 800,000 hectares, and the shallow soil cover an area of about 6 million hectares, and sandy soil is about 2 million hectares. For today, I will emphasize in saline soil. For saline soil in Thailand, it cover an area of 806,000 hectares. It can be divided into two types of saline soil. The first one is the inland saline soil. It's located in the northeastern region. It covers an area is about 360,000 hectares. And the second one is the coastal saline soil, cover an area of 444,000 hectares. This slide shows the outlook of saline soil in Thailand. When you come in the field, you can see the soil cut and indicator plants such as Acema cementosa and Salis indica. And you can see spotty growth of rice or the other cash crop. For salinity harmful, its effect include loss agricultural production, stream salinity, and damage to infrastructure, urban household, and environment costs. Shall we move to soil salinity management? I will divide into two parts. The first one I will talk about inland saline soil, and the second one I will talk about management of coastal saline soil. For inland saline soil, I will divide in slightly and moderately and severely and in the potential and land area. For slightly to moderately saline soil in Thailand are typical use for rice cultivation, but rice yield are very low, about 1 ton per hectare. And the guideline for rice cultivation recommended to the farmer were developed from research result and transferred to the farmer. This slide shows a successful economic management for rice cultivation. We start with the land leveling to reduce the soil accumulation in the soil surface. And we use a high result tolerant rice variety, namely Khao Dok Mali 105 or Jasmine Light. And for improved soil fertility, we recommend to apply organic fertilizer such as green manure, farm manure, and compost during land preparation. At the cultivation procedure, we recommend to transplanting of older seedling, closer spacing, and increased number of seedling. And after harvesting, we suggest to incorporate light store and mulching the soil surface. For the improvement of soil salinity, Land Development Department recommend to use green manure because of green manure play a role as a cheap nitrogen source. And the use of green manure has also been a practical method and suitable for managing salt-affected soil. For many studies, it found that Cedronia rostata, the stem nodulating legume, show high potential as a green manure in the rice system in the northeast of Thailand. However, the farmer can grow the other cash crop in saline condition by planting salt-tolerant varieties such as asparagus, tomato, Chinese lettuce, Chinese kale, cantaloupe, and safflower with suitable land preparation. And after planting, mulching is necessary for them. For the improved soil fertility, organic amendments as green manure, compost, and farmyard manure is recommended with appropriate irrigation. And for severely saline soil, halophytes such as Sporobolus virginicus or Dixicus, and salt tolerant tea, namely Acacia ambicep, are recommended for environmental rehabilitation. And the other method for management for severely saline soil is the engineering method. It could be used to improve severely saline soil. For this slide show open and subsurface drainage for leaching and drainage saline water. And for the potential south area or the upland area, reforestation of the recharge upland with the trees to lower the water table and to reduce discharge in the lowland is appropriate approach for salinity control. For the type of the tree is recommend is eucalyptus. It's a fast-growing tree and use a lot of water. And for the other way, Land Development Department has adopted a new approach to lower groundwater table by developing the use of groundwater in the recharge area or the upland area. And the farmer can use groundwater for crop irrigation because in this area, the water is a fresh water the farmer can use for agriculture. And after they use, it can reduce the water table and reduce distribution of saline soil in the discharge area or in the lowland area. Shall we move to the coastal saline soil? For coastal saline soils occur in the coastal area, may be characterized as heavy clay, and they subject to tidal influence and back it to sea water intrusion. It covers an area is about 444,000 hectares. For the management of coastal saline soil, we suggest that the farmer had to remove exchangeable sodium from the loess for the loose zone by using gypsum and to construct dye and or powder to prevent high tide from inundating the lands, which would get to regulate by and fresh water flow. And the farmer should to improve the land by reaching for plantation and grow salt-tolerant crops such as rice, coconuts, cantaloupe, taro, sweet potato, and Manila tamarind, etc. Let's move to the in conclusion. For the slightly for inland saline soils at the level of slightly and moderately saline soil, light cultivation with salt tolerant light variety and suitable soil improvement and appropriating planting procedure are recommended. And for severely saline soil, ecosystem rehabilitation is needed by planting halophyte and salt tolerant seed. And for the potential salt area, reforestation and developing shallow well are recommended. And for the coastal saline soil, construction dike or border and improve the land by letting for plantation salt tolerant variety is recommended. And all these recommendation, land development department transfer technology to the farmer and scaling up in the pilot area in many provinces in the northeastern part of Thailand. And this project is successful and the farmer is satisfied this project. Thank you very much for your attention.
Thank you very much, Dr. Pirach, to you. As for the session before, I kindly ask you to please stay with us. We are going to have one more presentation from India, and then we will open the floor for another round of discussion. Okay, so participants, as usual, I kindly invite you to write your question in the Q&A or think about your intervention for the open discussion. Now I would like to pass the floor to the last speaker of the day, Dr. Rai from India. Many thanks for waiting so long for taking the floor. Dr. Rai is the director of the Central Soil Salinity Research Institute of the Indian Council of Agricultural Research, and he will tell us about issues and strategies for managing salt-affected ecologies. So, Director Rai, the floor is yours. Thanks.
Thank you, ma'am. Just I'm sharing the screen. Is it visible? Ma'am, is it visible, my slides?
Yes, now yes.
So, a very good afternoon and thanks all for waiting for my presentation. Actually, today being the last speaker, there will be a lot of sum up exercise because many speakers have spoken on few aspects which I will like to cover. So here I'm going to give my thought on the issues and strategy for managing the salt affected ecology with special reference to Indian condition. Here, my talk will be in this diversity of salt affected soils and its problem, then impact of the natural events like the climate change, then problem of soil quality assessment and its parameterization under the salt affected soil condition and the issues, then rehabilitation are the management options that is being practiced in India and what are the future amendments are the management practices that we are under the evaluating it and what are the way forward. So quickly moving to the content. In India, we are mostly characterizing the salinity landscape either in the normal soil condition or the saline sodic or the sodic soils, depending upon the preponderance of the chloride, sulfate, or the carbonate and bicarbonate salts. And depending upon the composition of the salt, the crop respond to the salinity either because of the excess of the sodium ion or because of the osmotic effects or by the ionic toxicity or the deficiency. And keeping these few points in view, we develop our management strategy here. And if you see, these salt affected soils, they are distributed almost all over the globe and covering almost entire soil orders, especially in the coastal region as well as inland region, particularly in the Asian region, where the inland as well as the coastal both sizable area is present. And in this area, if we come to the India, Dr. Gajendra and Dr. Banyal both have covered that we are having about 6.73 million hectares of the land at present. Our present estimate shows, and under the salinity as well as the sodicity condition affected, including both coastal as well as the inland salinity affected areas. Most of the area of the salt affected, particularly the sodic land, most of the 50% of the land is here in the Indo-Gangetic plain, and the salinity affected land is located here in the Gujarat as well as the entire coastal region of the country. And these are having, because of the different characteristics and the different drivers of the soil salinization certification, they need special kind of the management. And accordingly, here in India, we are having a network of the centers who are located in the specific pocket to deal with the specific kind of the salinity. Like in Vertisol region, we are having one regional research station of Central Soil Salinity Research Institute. Likewise, in coastal region, we are having network, our one regional research station in the West Bengal here near the Canning town in West Bengal. And there are certain cooperating centers throughout this coastal belt in agriculture research universities. With this, in a network mode, we are trying to handle this problem. Likewise, the irrigation water quality is a big challenge in India. Here, being the monsoonal climate, the rainfall is only limited to the rainy season, that is from July to September, October, and rest of remaining 4-5 months of the growing season, we have to depend on the irrigation. And the groundwater available for irrigation in many pockets is this yellow line. You can see that is the the saline affected areas, and the green and this light green part is having the sodicity affected water. And because of this water quality and the growing intensification of the agriculture, the complexity of the soil salinization and the sodification is increasing. And what is the present estimate? What we are having about 6.7 million hectare. If business as usual goes as usual, then by 2050 there may be another 10 million hectare that may be added into the salt affected category. As I was mentioning, that this is the region where we are getting the accumulation of the salt in the surface region, and this is the region means June to October, we are getting the salinity flux downward. And in this way, cyclic mode, the salinity fluctuate, and there is some sort of equilibrium in this region. But because of the increased dependence of the poor quality water irrigation or the increased demand for the water from other sectors, so we are having less allocation for the water for agriculture. Then climate change scenario, because of the change in the rainfall pattern and the change in the temperature events, there is increase in the evapotranspiration demand, and we have to depend more on the supplemental irrigation through groundwater that is of poor quality. And all these, apart from that, in coastal region, because of the climate change, saline water intrusion and the seawater level rise, and because of the tidal events, there is another reason, chances of the secondary salinization, and all these may complex the situation by increased soil salinity if we are sufficient care as is not taken. Presently, we are using the 3 strategy to manage the soil depending upon the soil characteristics. That is the use of the amendment in the sodic and saline sodic soil conditions, where the preponderance of the carbonate and bicarbonate salts are more. So till now we were having heavily dependent on the mineral gypsum, but with some new research and development, we have developed the elemental sulfur based formulation, and we have studied the flue gas desulfurization gypsum, because a lot of gypsum is synthetic gypsum is now available in the country. And besides, several biological or the organic amendments also we are evaluating, so that we can reduce the dependence on the mined gypsum. And then subsurface technology and the cut soiler or the land modification technology, these are the another system that we are using to manage this in integration with the salt tolerant varieties, because if you are introducing the salt tolerant variety, the need of the reclamation is reduced. So we can economize our reclamation and the management by introduction of the. So these are the three strategy on which in India we are focusing, so that we can get the soil salinity management by at the lower cost with increased farmers' income. Here, about till now, our focus was just to manage the salinity by applying the amendment and all those things. Now, a second generation problem has come in those areas where the reclamation has been taken up, either because of the resodification or the resalinization. Some sort of problem has reoccurred, and now we cannot go for the blanket recommendation. So just to prioritize the area for the treatment or to allocate the resources for the reclamation, we need a robust index-based mapping, so that we can formulate, okay, these are the area where we can go for reclamation. So we are working on this issue, and here there is a problem worldwide. Still now, for salt affected soils, we are not able to develop a very robust soil quality assessment where the decisions are based on the yield goals. And because this is only because the huge spatial and the temporal variation, once these soils are put under the management, there are various spatial and temporal variations, and that lead to the identifying the good minimum data set, so that a robust soil quality index can be developed. And if you see, and to this problem, because of the climate change, another dimension is being added into this, and different part of the globe, if you see, different kind of issues are emerging besides the inherent problem of the salinity and sodicity, and this is adding another dimension to the or the problem, you can say, challenge in developing the robust soil quality index based prioritization of the treatment and the management options. So if you see, till now we have searched the global literature available, we have seen that about 22 to 25% soil quality index, they are dependent upon the pH, and EC is considered as come up as the most master indicator. Besides that, clay, ESP, and organic carbon is there. And depending, you can see the overall throughout the globe in salt affected regions, these are the indicators that have been identified to develop the master. But what is the drawback? That there is no biological or mostly chemical parameters are coming up, but the soil is a living system, and it has another dimension if you are using the biological indicator also. So this is the problem. This is the one issue that the soil science community is facing, or the management planning is affected. And if you see, whatever the soil quality index has been developed, most of the indexes developed throughout the world, it is using more than 15 attributes to predict about 60 to 80% variability in the production goals. And 16 or the 15, 13, 20 variables are very huge number. It will be very difficult to monitor as well as measure. So there is a need for working on these issues, so that we can come up with an agreeable soil quality index for prioritization of the treatment area or the reclamation plan for a particular region or the state. So these are the one issue that we were have highlighted. And then what attempt we are doing in India as far as the managing the salt affected ecologies here till now, since 1969, in the inception of the Central Soil Salinity Research Institute, we are largely dependent upon the this gypsum technology, where we are applying the gypsum depending upon the gypsum requirement. Then in for the saline affected area, saline and waterlogged affected area, saline waterlogged affected area, we are heavily dependent on the subsurface drainage. And in the canal irrigation command areas, where there is a process of problem of the water logging because of the seepage from the canal, there we are using this preventive technique of the bio drainage. And then in coastal region, this technology of this our institute has come up very well. That is the land shaping technique, where the crop, fish, and the vegetable crops are being integrated by just modifying the land so that flooding and the salinity events can be managed. So till now, using this technology, we are in position to manage about 2.1 million hectares of the land. But as I have mentioned, there is a problem of gypsum quality. Dr. Gajendra also mentioned that availability of gypsum is the problem, and that too a mineral mined gypsum. So there is another ecological and the environmental aspect is also associated with this. With the change in the technological options and the availability of several byproducts. So just to promote, Government of India is also having a lot of focus on promoting the circular economy. So just to link that circular economy aspect, we have developed several formulation that is based on the sulfur and the FGD gypsum, so that a specific problem can be solved. And we are testing it in active collaboration with the farmers. And this sulfur industrial partner Reliance Industries Limited, and then this is our in-house development by our scientists. And we were able to test it, and we found that these are the good alternative to the mined gypsum. They are less bulky, more efficient, and the cost of reclamation will come down once it is available to the farmer. So this is just a technological aspect of this sulfur-based formulation. As initially sulfur were studied for the reclamation, but now we have introduced some formulation aspects so that its reactivity is enhanced, and in pH of soil of pH 10 or even higher, it can be oxidized very quickly, and it can give the better reclamation in compared to the mineral gypsum. Likewise, we have evaluated the flue gas desulfurization gypsum because of the intervention of the Green Tribunal in India. Now the most of the thermal electricity generation in India is based on the coal-fired plants, and their emission of the gases is very serious issue. So now we are converting all those thermal power plants equipped with this flue gas desulfurization technology so that we can recapture the sulfur that is going into the atmosphere. And now we are getting the this gypsum, man-made gypsum, or the synthetic gypsum. It is of very good quality. Unfortunately, there is no any toxicity, and we have given the guideline that any flue gas desulfurization gypsum, it should have the ecological risk assessment code less than 10, so that there should not be any risk if it is applied at the rate required for reclamation of the sodic soils. Okay, likewise, we are managing the because in subsurface drainage, lot of cost is involved, and many times it is not possible to reclaim the entire area because it is a community driven approach. Under that situation, we are focusing on managing the root zone so that by manipulating the seasonal dynamics of the saline upward and downward flux, we can manage the root zone, and we can integrate the salt tolerant varieties so that with minimal saline groundwater irrigation, we can get the crop without long-term impact of soil salinization or the salinity buildup. And this technology has been perfected, and now we are testing at the farmers field also. Likewise, we have started evaluating these city waste or the municipal solid waste compost. That is the another issue of the rapid urbanization in a country like India. Here we are adding the value to this by using the sulfur oxidizers and the sulfur elements so that we can increase the total alkali neutralization potential by increasing the acidity. And we could found that this is a very good reclamation material as far as this alkali water irrigated area is concerned. There, with minimal intervention, we can manage that water for the well-being of the farmers and the good crop growth. Likewise, the press mud is another byproduct that is available in the sugarcane industry, and that also can be integrated very nicely with the for the irrigation RSC water, means alkali water irrigated areas, and by even up to irrigation with the 6 milliequivalent of RSC, means residual sodium carbonate, we are able to treat this water and manage the soil sodicity below permissible limit without impacting the crop if we are using this intervention. Likewise, as Dr. Gajendra mentioned, that this is the new age technology that I have mentioned that we are evaluating, that to manage the root zone salinity by using the cut soiler. Here, besides the managing the cut soiler, we are managing the subsurface sodicity just to increase the option of the crop by increasing for the chances of crop diversification. Because till now in India, just to economize the cost of reclamation, we were mostly dependent on the applying the 50% of the total gypsum requirement. So still some residual sodicity exists in those reclaimed lands, and there is a very limited chance of growing the high value crop, as Ma'am Kevin was asking about the horticultural crops. So option of getting the horticultural crop in those lands were less. So now we are using this technology to manage the subsurface sodicity by placing the gypsum below the root zone, or 60 to 70 centimeter below the surface, so that we can go for crops with deeper root zone like horticultural crops. So these are the area where we are working at present, and its effect on the groundwater quality as well as the groundwater depth variability in throughout the zone. We are monitoring with our partner from JIRCAS. So as Dr. Wen said, that we should not only transform the soil from non-productive to only productive soil, rather it should be able to meet out all the ecosystem goals like food and feed, energy, water supply, biodiversity production, cultural and the national heritage, waste utilization, environmental and the climate change, so that all the sustainable development goals associated with agriculture and allied sector can be those can be fulfilled, like the no poverty, zero hunger, good health and well-being, clean water, then climate change related issues, then responsible consumption by utilizing the waste and all those things, so that life on land is secured and life below the water is also secured. So these are the things that we have to think, being a soil scientist, are the working with the on the ecological aspect. So keeping that in mind, what this is my thought, that the future challenges need to be addressed by, because database is very important. We need to have the updated database for this inland as well as the coastal salinity affected areas, and a master indicator or the soil quality index should be there, so that using those index we can link it with the production aspect or the production goals, and accordingly we can uh, find out the area or the prioritize the area where with the minimum investment we can get maximum gain. So this is the idea behind this. And then looking for out the simple and the low robust and the low cost high throughput indicators, again for the same thing. And then understanding the hydrological cycle of the salt affected region, because of the added irrigation, because of the seawater intrusion, there is probability and the increased extraction, groundwater extraction also, there is chances of the change in the hydrological cycle. And once hydrological cycle is impacted, it will have a very long time to revert back. So this need to be taken care very urgently. And then site specific special management practices need to be developed, so then that by 2050, as far as India is concerned, we are expecting that if business as usual goes as usual, then there may be another about total 17 million hectares of land may become soil salinized. So for to addressing all those things, we are working on these aspects, so that we can manage and we can halt the soil salinization and get the land degradation neutrality target achieved by 2030. Thank you very much. This is from my side.
Thank you very much, Dr. Rai. It was a very, very good presentation, very clear. I'm now opening the floor for discussion. We have about 10 minutes for that. Again, I will start breaking the ice and I will go back to Dr. Pirach, so that Dr. Rai, you can take a rest because you talk for a long time. So, Dr. Pirach, I have a couple of questions for you. also trying to make the link with the first part of this webinar. So you presented quite a number of practices for inland and coastal salinity. I was wondering if Thailand would consider eventually developing or using a subsoiler like the one developed by India, that eventually can also help you with the crop residues management, no? That it's still a sort of issue for farmers.
Okay, and for this point, I think for the subtrailer is the aim of this concept is for reaching salt from the soil surface. And for this technique, I think it's a high cost, and it maybe it's not practical for the farmer in Thailand. But however, it can be done by the government to subsidize to the farmer or in the last area. Okay, I think it can do in the last area by government. But for the farmer, I think that it's not suitable for them.
Because the cost would still be too high, right? Okay, thank you very much. Let me ask a question to Dr. Rai, and meanwhile, I invite all participants to also eventually raise their hand or write their question in the Q&A so that we can address them. Dr. Rai, my question for you is a bit more on a political level, because you touched on a topic that I think it's very relevant not only for India, but for the entire region. And this is water quality. So I saw it in many other countries that there is a sort of conflict on water use between sectors. So I was wondering if in India there is any intersectoral legal instruments that prevent and regulate the use of, for example, wastewater from the industry in agriculture, because I saw that in some countries this is not regulated and can lead to crop failure or like high level of pollutions in the fields. So yeah, this is my question.
Actually, depending upon the sectors, the nature of the pollutants also vary. So suitability of that water for the agriculture will depend upon from which industry it is coming out. So in India, there is a pollution control board that regulates the effluent quality, and based on that only they allow it to enter into the either in the stream, surface water stream. It is true that there are many type of the people that some are law abiding, some may be the miscreants also. So depending upon that, it may vary, but there are guidelines are there, and there are the treatment plants also. It is and in most of the municipalities now, the effluent treatment plants are installed, and based on those quality of water only we can use to we can release those water into the water stream, so that water quality is not affected. But the scale of the problem in India is very huge. Here the water requirement for all sectors are very high. That's why there will be always a competing demand, not only for the domestic consumption, but for the agricultural use as well as industrial use, that too mostly in the non-monsoon time, that is during the winter season here. That is the problem. At that time, we have to evolve that thing. That is still in the process of evolution, and the course correction is there.
But
So
at
definitely,
present, is there
present
is
is
there any authority that check on the water quality
yes,
coming out of the industry?
yeah, water pollution control board. There is a central pollution control board in the country. They are having the responsibility to monitor it and certify that whether that water is suitable for releasing into the water, surface water streams or not. So there is imposition, and they have these
Thank you
stringent
very much.
guidelines.
This is very good to hear. Thank you very much. Because eventually I'm thinking if we can share the India's experience on this with other countries so that, we can lead for a change.
Yes, sure.
I have a question in the chat. It's the following. Can you please explain about the depth of drains in the drainage system in India and explain about the management of saline drains? Where is it usually directed and there is no environmental problem?
Actually, the subsurface drainage system that is installed in our country is in the waterlogged saline areas where the water table depth is within 1 to 2 meter, or even if it is on the surface. So if water table is near the root zone, means within 2 meter depth, then there is very likeliness that the saline water will rise to this root zone by the capillary rise, and that makes the failure of the crop. So under that situation, we try to install these drains, and installation of drain is about 2 meter, so that entire root zone is free from the capillary rise of the water. As far as off-site pollution of the salt load is concerned, being the monsoonal climate, that is the one we can say the boon for us, that at that time the river water volume is huge, and at that time only we pump this water to discharge into the river stream, so that the diluted water will not have the salinity objectionable for whether it is for the agricultural use or the domestic consumption. So like that, we are using disposing the effluent from the subsurface drainage.
Thank you very much. I think it was very clear. I have another question for you. So the big problem in our SAS is the lack of fresh water to leach the soluble salt out of the soils. Could you, or also any other speaker, provide some advice or suggested technique for dealing with these problem issues?
Uh, I can add my point. uh, uh, this in those area where the good quality water is not available for the leaching. In India also there are some situations in dry land salinity affected areas. There we advise the farmers to prevent the surface runoff, stop whatever the rain they are getting to leach the soil in that pocket of the land only, so that whatever the rain is available, it will leach out the salt. Our study says that if 400 rainfall is available, then the root zone, about 70 to 80% of the salt can be washed out in that rainfall event uh, below the root zone. And besides that, we have developed certain conjunctive use technology also, that depending upon the availability of the good quality water and the poor quality water, we can apply the poor quality water at the physiological stages which are not sensitive to salinity stress. Means avoiding the sensitive stages, we promote the use of the poor quality water, and leaching of that salt accumulated during the winter season in our country by accumulating the rainwater, or maybe allowing the rainwater to leach through the soil, so that whatever the salt that was accumulated in the previous year, that get washed out. So this is the way we are using the conjunctive use of good quality and the poor quality water as well as the rainwater, and integrating it with salt tolerant varieties, because there are certain salt in India, in rice and wheat we have certain varieties which can tolerate salinity up to say 7 to 8 decisiemens, and that can be integrated, then it will decrease the chances of the crop failure.
Thank you very much. Anyone else among the panelists feel like adding to what Dr. Rai said?
Yeah, there are certain water saving techniques also, like using drip irrigation to apply a minimum water and thus the minimum salt. If the salty water is only available, that will also beneficial to the areas where we are only having saline water. Apart from those techniques Dr. Rai has mentioned.
Thank you very much. We have a very last question because we are running late. So the question is for everybody. Like a participant is asking if you can please provide some suggestions or recommendations on how to map salt-affected soils in GIS and RS. Can any of you help on this? So it's about mapping.
Yeah.
If not, we will redirect the question to GIS expert. I'm also not a GIS expert, so I cannot help. Okay, I will, Dr. Shah, I will find a GIS expert to help you. Actually, yesterday, Miss Maria Koniushkova from the GSP presented about the salt-affected soil map prepared by the Global Soil Partnership of FAO in collaboration with countries. And that work implied a lot of mapping efforts. So my suggestion is that I put you in touch with Ms. Koniushkova and the GSP, so the Global Soil Partnership mapping team. They will be able to support you. And if anyone else requires this type of support, please send me an email and I will do the same with you. Okay, I receive a request for talking live. Nice surprise. Good. Dr. Pillai, please, quickly, because we're running late.
Yeah, thank you. Just I wish to tell that whatever support with respect to GIS or salinity mapping, we'll be happy to do that. That's what I want.
Okay, thank you. Thank you very much. So do you mind if I put you in touch with Dr. Shah and Nawaz?
Yeah, please.
Okay. Thank you. Thank you very much. Let me take note of it, otherwise I forget. Okay. Thank you very much. Well, of course, to all speakers that shared their experience with us today about their countries, about the technologies they developed and the practices that are implementing. I found it extremely useful, and I hope that this is a shared feeling. I would also like to thank all participants that stood with us until the very end. I hope you found it pleasant, that you had some fun, because that's also important, and mostly that you found it useful, so that maybe you learned something that you can apply in your own country. So this is the end of the webinar. As usual, I will send to all registered participants a copy of the presentation, the contact details of speakers in case you like to reach out for them, and also the video recording of the webinar. I thank you again for your time and support and enthusiasm. I wait for you at the next webinar towards the end of July, and I wish you a good rest of the day. Thank you all.
Thank you. Thank you.
Thank you very much.
Thank you.
Thank you.